Hi class, this is Dr. Karsten and I am going to be doing lesson 11 problem set from Engage New York, grade 4, module 5. And unfortunately when I was working on recording this lesson, my camera glitched out, or my system glitched out, and it recorded about 2/3 of the lesson. But as I was just finishing 1A from the problem set and moving on to 2, the system decided to glitch out. So I apologize in advance for that, or I guess you've probably hopefully already watched the first video. So I'm going to do the problem set in this video. I am not going to go over anything, so if you did not watch the previous video where I explained the lesson, you definitely need to go back or you will be lost by the time we get to the last problem in this problem set. So definitely watch that first thing and then watch this the problem set questions. I'm going to be doing a bunch of them. And I'm kind of sad because I did a really great job the first time, so I hope it goes well this time. Alright, so this first problem, let's take a look and see. I'm just going to slide it up so we have a little bit more room. It says label each number line with the fractions shown on the tape diagram. Circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. Okay, so the first thing I have to do is I have to take a look at my tape diagram and figure out what fraction is being represented here. What are these parts all representing? Now, on my number line, I know that I'm always going to start with a 0 here, if I know that this is one whole, which I do because of the bracket. And then I don't know what I'm going to have written here because I need to figure out what my denominator is first. So since we have 1, 2, 3, 4 units, or 4 parts, and again we see that on our number line as well, 1, 2, 3, 4, I know that these are all fourths, and I can put a 4 in both my denominators here. It's the total. Remember, this represents the number, total number of units. Now, this has gone, if I go from here to here, I've gone 1/4. If I continue along, I now have gone 2/4. I can keep going, and I'm at 3/4, and then I go to 4/4. And remember, 4 over 4 just means that it's one whole, and you can see it is the entire tape diagram. So this represents the whole way, or 1. So now the second piece of this said that we were to circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. This is the shaded part, and it ends right here, which corresponds or lines up right here with 1/4. So I'm going to go ahead and circle that. And now I know that that labels 1/4 or 1/4 on the number line. Now, let's go ahead and take a look at B because we are actually going to need 1B in order to do problem 2A. So if I'm looking at 1B, again, I'm going to start by labeling, putting a 0 here. I don't know my denominator yet. So let's figure out our denominator for this number line and also for this tape diagram. And the denominator, again, is the total number of units that makes up one whole. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to put an 8 here. Now, what I want to point out to you is I like to call them hops. I think I may have mentioned it before. When I'm talking about the parts here, you cannot count this as being 1. This is 0. Count your hops. So count the distance that you've gone. 1, 2, 3, 4. See how my pen is hopping? And at this point it would have gone 8 hops. So I can go ahead and put 8 eighths there. And now let's label the rest of all of these points on the number line. So we have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and we already had our 8/8 in there. And now we have to circle the fraction right here that labels the shaded part of the tape diagram. And that's going to be right here. The tape diagram ends here. That's this mark, so I'm going to go ahead and circle that. Alright, this is pretty easy. So I have full faith that you're going to be able to do C by yourself. Now, I know that for question number 2, we are going to have to use these two numbers. So let's remember that in 1A, we have 1/4, And in 1b, we have 2/8. And let's go ahead and let's read what the question is telling us. And then we're actually going to jump back to this page just to look at it one more time. Okay, so in problem 2, it says write a number of sentences using multiplication to show. And for the first one, let me just slide it over a little. We want to show that the fraction represented in 1a, which, if you remember, that's going to be 1/4, is equivalent to the fraction represented in 1b, which was 2/8. Let's just look at that visually and see if that makes sense to us. So if I slide this back over, what I can see is that 1/4 and 2/8 really do line up at the same point on these tape diagrams that are both the same length and are both labeled as being 1. So given that, I can visually see that 1/4 is equivalent to 2/8, but being able to see it is not as good as being able to prove it using math. So let's go ahead and prove it. So we already know that we are going to show that 1/4 is equivalent or equal to 2/8, and we have to use multiplication to do that. So let's go ahead and set that up. So I have 1/4, that's my original fraction. This is where I'm going to show what I'm doing to my original fraction, and I'm going to show what my final fraction is, which was 2/8. I'm going to go ahead and write 1/4, and then we're using multiplication. So now, let's just use our numerator, because that's nice and easy. How can I turn 1 into 2? So 1 times what number is going to give me a 2? Or, let me do the inverse. 2 divided by 1 is going to give me that number. Well, if I take 2 and I divide it by 1, I'm just going to get 2. So that's nice and easy. So now I know that 2 is also the number here, which means that I'm multiplying by 2. And that's exactly what we did. We were splitting those fourths into 8s. We were dividing them in half, or multiplying times 2. Remember that when we multiply, when we are decomposing, we multiply because we are making more pieces. Okay, so we have proven this. I believe that you guys are able to do B on your own. You're going to be using from 1A what you have, which is 1/4, but then whatever you got in 1C is what you are going to be turning that into. You're going to show that they are equivalent fractions. Okay, let's go ahead and take a look at number 3. So for number 3, it says use each shaded tape diagram below as a ruler to draw a number line. Mark each number line with fractional units shown on the tape diagram and circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. So this is very similar to 1A, except for in this case, they did not give us what our dropped something. They did not give us the number line. We're going to have to draw that in ourselves, but that's not a big deal. So let's go ahead and do that. So remember, when you're drawing your number line, you're going to draw as straight a line as you can. If you have a ruler, that's fabulous. If not, try and get it nice and straight. And you want to go a little bit beyond or past the ends of your tape diagram. And then you want to mark off or align, put marks that align themselves with the ends of your tape diagram. We already know that this is going to be 0. I haven't yet figured out what my denominator is, and I don't know this side at all yet. But this is going to be equivalent to 1 because it's the whole thing, and they have it bracketed off for us. So now I can take a look at my tape diagram, and I can see that I have 1, 2, 3 pieces. So now I know my denominator is going to be 3 for the total number of units or parts that are represented in the tape diagram or in the number line from 0 to 1. So now I can go ahead and put a 3 here, and since I know that this has to be equal to 1 whole, I can actually go and slip that 3 right in there. Okay, so let's go ahead and add the rest of the fractions. So here we're going to have from 0/3, we go to here, and we've traveled 1/3 of the way, or we have 1/3. Now we continue, and we get to 2/3. And if we continue, we would get to that 3/3, which is equal to 1. So now, let's figure out, remember the second part of it was that we have to circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. Well, here's the end of the shaded part of our tape diagram, so this is the fraction that labels it. All right. So because I know that the next question is again going to use both A and B, let's go ahead and move forward and make a quick tape diagram for B. And I think you're getting it now. So I'm going to kind of put my end points here, align them with the ends. I'm going to put 0 here. And now let's go ahead and figure out how many pieces was this tape diagram broken up into. How many pieces was it decomposed into? 1, 2, 3, 4, 5, 6. So now I know that my denominator is going to be 6 because I have 6 equal parts. And since this is going to be one whole because of the bracketed off part, I can go ahead and put my 6 there because 6 over 6 is equal to 1. 6 pieces, divide something into 6 pieces, have all 6, it's equal to 1. So now since I know those are 6, I can label them here on my number line. So I have 0/6 when I start here, then I have 1/6, 2/6, 3/6, 4/6, and 5/6. And the end of this number line, of the shaded in region, ends right here at 4/6. So I can see that. So now I'm going to remember that the first one was 2/3, the second one was 4/6, and let's jump over to problem 4. Now, in problem 4, let me slide it down for us. Sorry about that. I'll get it lined up first eventually. Here we go. So in problem 4, it says write number sentences using division. So we want to use division to show that, let me bring this back, that 2/3 was equivalent to 4/6. And visually, I can see that they do line up and that the shaded area is the same amount of the whole in both of these fractions, or in both of these tape diagrams and number lines. So let's go ahead and prove that. So my first fraction, so in 3A it was 2/3, and in 3B it was 4/6. So I'm just going to jot those for us so we have them. Now, since we are using division, we must be composing or putting the pieces back together. So each piece is going to be bigger, but there are fewer of them. So let me go ahead and start with this because we are taking these little itty bitty sixths and we are going to turn them into much larger thirds. So let me write 4/6 to start with. And let me get everything set up. I know where I'm headed. I'm going for that 2/3. I want to prove that they're equivalent using math. And I'm doing this with division because I'm composing. Okay, so we write what we're starting with again. And now I have to figure out, and we can use the numerator or denominator. I'm going to start with my numerator. I want to show that 4 divided by some number is equal to 2. So again, if 4 divided by some number is equal to 2, another way to do that is to say 4 divided by that 2 is equal to that number. The reason for this again is because I can say that I have 4 as my whole and that 2 is a part. What is the other part? Well, 2 times this number is 4, or 4 divided by this number is my missing number, just like 4 divided by my missing number is 2. So when I do that, I realize that all of these are 2's. So now I know 4 divided by 2 is 2, and I can go ahead and put that into my number sentence. So when I look at this, I can see that 4 divided by 2 is 2, 6 divided by 2 is 3, and yeah, it worked. We just proved it mathematically. So I believe that you can do 4B, which is very similar. We've been doing a bunch of these now. We've been actually working on these for a few days. So I think that you'll be able to do it. Let's take a look at problem number 5, because this is where it gets a little tricky, similar to that third example that I did in the problem set in the previous video. This is where things are getting a little bit different. So let's read and see what it says. It says partition a number line from 0 to 1 into fifths. Uh-oh. Something just happened again. Oh, we're good. Sorry about that. Nothing bad happened. My computer just went into sleep mode, which hopefully means nothing bad is happening here, and it's recording because I don't think I have the energy to do this again tonight. Okay, so again, let me read it. Partition a number line from 0 to 1 into fifths. So let's just start with that. So I don't know if you have noticed that the word partition, which is a word that I've been using a lot today and for the last, I guess, 2 days, has the word part in it. When you're partitioning something, you're splitting it up or dividing it up into its parts. We're cutting it up into the parts. So I wanted to point that out to you because I've been using that word a lot. So let me first do my number line. And my number line is going from 0 to 1. But again, since I'm going to be doing it in fifths, I don't want to write 0 and 1. I want to write 0 fifths. And I happen to know that 1, when it's written, let me slide this down, into fifths is going to be 5 fifths, because that's just equal to 1. Numerator and denominator are matching. So now I need to try and divide this into 5 equal parts, or partition it into 5 equal parts. And I'm going to do the best I can to try and make these pretty equal. Okay, that's not bad. So again, let's go ahead and now write in what all fractions are being represented here. So I have 0 fifths when I start. I'm going to make one hop and I have 1 fifth. I've gone 1/5 of the way. Go another one. Now I have 2 fifths. I'm going to go another one and I have 3 fifths. I'm going to go to another one and I have 4 fifths. And then if I make that last hop, I have 5 fifths. So 1 fifth, 2 fifths, 3 fifths, 4 fifths, and 5 fifths. Now, it is asking us to decompose 2 fifths into 4 equal lengths. So let me mark off that 2 fifths with a point. And now it says decompose it into 4 equal lengths. Do not make 4 marks in here or 4 marks in here, because you're doing it wrong. Remember, we want to take both of these units, 2 units, and decompose them into 4 equal lengths. Now, I'm going to jump down to B, 5B, and I'm going to do it mathematically because, again, I think for a lot of you, that's going to be helpful. If you can see that I need to divide these 2 and make them into 4, go for it. But I'm going to go ahead and do it mathematically for you, just so that you have a way of doing this that might make more sense for you. All right, so I'm starting with 2 fifths, and I want to decompose that into 4 equal lengths. So I'm going to write 2 fifths, and remember when we're decomposing, we are actually multiplying. And I'm going to show what my original equation was and set up my multiplication. And now, since it says that I need to turn these 2 pieces into 4 equal lengths, I'm going to put a 4 in the numerator because that's the number of equal lengths that I'm going to have. So I'm going to go ahead and write that over here, and now I just have to figure out 2 times what number gives me 4. Or, inversely, 4 divided by 2 is going to give me what number? And you should get a 2 in both those spots. So I'm going to go ahead and write my 2 in there. And now I can say 2 times 2 is 4, and 5 times 2 is 10. So now what I know is that I am going to split or partition each of these into 2 pieces. So let me do that. And now I've created tenths. And I can go ahead and I can look at that. So here I have 0 tenths. I have 1 tenth. I have 2 tenths. Sorry, they're so small. Here I have 3 tenths. Here I have 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, and 10 tenths. And again, I didn't have to actually draw them all in here. I only had to draw them in here, but I did want to model that for you. So you did not have to put all these tenths in. You just had to put in 0 tenths, 1 tenth, 2 tenths, and 3 tenths, and 4 tenths. You just had to get up to that. So now we have modeled it in here on our number line that 2/5 is the same as 4 tenths, they're equivalent, and we have modeled it mathematically. So now you are going to, here it says write a number sentence using division to show what fraction represented on the number line is equivalent to 2/5. I'm just going to give you a hint with this because I know this is kind of the new part and I wish there was another problem. I guess we could always go into the homework if we need more work with this. But you're going to start with 4 tenths. And then your goal is to model turning that 4 tenths back into 2 tenths. So now we are composing, 2/5, not 2 tenths, because that makes no sense. So here I'm trying to be nice and I'm messing you up. And then I'm going to remind you that we always show what we're starting with, and since we are composing, we are actually going to be dividing, because you're turning 4 into a smaller number, so clearly you're dividing. I'm going to let you work through that part. So again, I'm really sorry that this was broken up into 2 separate videos. Again, it was a little glitchy. Hopefully it all comes out really good this time. If there's any problem, let me know when we get back into our Google Classroom. And I look forward to seeing you there. Again, I will not be posting any new lessons for the next 2 days because our school is doing virtual field trips. So I will be posting those in the afternoon. But for now, you have these two videos to look at. And this will give us all a chance to catch up. And I will be available to go over these problems together tomorrow morning. All right. Have a great night, and I will see you in our Google Classroom.